Thank you. And it's a nice follow-up on the first part of Colin's presentation, which was on crowdsourcing. So I was asked to speak on optimization for crowdsourcing and education. I'm not going to speak on education very much because I haven't done that much work, but I've done some work on crowdsourcing, and in particular in the context of sequential optimization, which is what I'm going to be talking about. It is really nice to hear the word POMDP in the morning session come in twice. I feel like I'm in an AI setting, so I'm going to be talking more about POMDPs. Just to start, this is joint work with Dan Weld. Most of this work has happened at University of Washington. Even after my coming back to India, some of the work that has been happening in this particular field is with Dan Weld and two of our students who have gotten degrees at University of, or about to get degrees at University of Washington. So this is the 30,000 feet view. Crowdsourcing has become huge, and this is the probably only slide I'm going to connect with social good. So crowdsourcing is social good from one vantage point. It has starting 2006 when the word crowdsourcing was formed, and then Amazon Mechanical Turk and many different platforms have really made crowdsourcing go very huge and has grown really rapidly. And I would make the point that it democratizes labor, and this is, I think, also the point that Colin was trying to make, that now we can give labor to a lot of people in the world. At the same time, there are some challenges in making crowdsourcing as successful as we want it to be, and it is our thesis that AI, machine learning optimization, can really make crowdsourcing achieve its potential. It can reduce work errors, and in our experiments we have sometimes been able to reduce errors by up to 85%. So we have really made sometimes we have found crowdsourcing to be super successful, okay, using AI techniques. So now I don't have to go too much into how crowdsourcing came up. Wikipedia is one of the first examples of crowdsourced encyclopedia, and look at the viral growth of Wikipedia articles that happened when people got interested. Citizen science was being referred to by Bart earlier, and Galaxy Zoo was one such example, which was getting 50 million classifications in a year, which machine learning algorithms were not able to do at the time. And it was not just that, the human workers, human citizen scientists actually ended up discovering special form of galaxies known as the P galaxies, which the astronomers had no idea about. Most of my talk is going to be about labor marketplaces, which are projected to grow by $5 billion by 2018. These are older projections and some of the older statistics, because I couldn't find the new statistics. But basically, for example, at Amazon Mechanical Turk, we had more than 500,000 workers 3-4 years ago, and Odesk was seeing 35 million hours clocked in their platform. In 2012, now they have become Upwork. So there's so much going on. There's so many very interesting strengths which got me really excited about crowdsourcing. For example, world becoming a unified labor force, like a global meritocracy of kind. People, whether you are in India, whether you are in Africa, whether you are in some a Pacific island, as long as you have internet connectivity and you have a skill to monetize digitally, then you can probably get work. This is such a cool thing for mankind in general. And of course, it had many other strengths. Not from the social side, social good aspect, like it was perfect for startups, it was cloud computing for human work. Really interesting new applications could come about. For example, one of my colleagues thought about an app for blind people, where blind people stuck in a new circumstance can actually ask a question and some crowd worker can answer their question based on the image that they are sending. Things that you would not have expected if such a thing was not available, and so on and so forth. And you can find pretty much every kind of expertise on a crowdsourcing platform. At the same time, there are lots of challenges, which is what got us interested. The most important challenge was high variance in worker quality. There are challenges about how to track the quality of output, and in general broad challenges about how do you get high quality output, because these are crowd workers. Some workers are awesome, some workers are not that great, some workers need training. How do you manage this large enterprise? And there are many other things where AI can play a role, like usually you divide a complex task into small micro tasks, and so how do you divide it, how do you test such workflows, how do you optimize them, how do you figure out who's the right worker to be working on my kind of tasks, and so on and so forth. So we have really worked very hard on demonstrating the value of AI and machine learning for crowdsourcing. At a high level, it works like this, that imagine this is an AI agent, this is a requester who is telling you what tasks need to be solved, and every AI system is operating in some environment, and so here our environment is a crowdsourcing platform. And so when a new task comes along, the AI system figures out which jobs to give out, and when work comes out, you can do your learning and you can do your planning. So you can ask questions like, what are my workflow parameters, what are the optimal parameters what are individual workers' abilities, what are they good at, what are they may not be as good at, how difficult is my task, and so on and so forth. And by learning all these parameters, then you can control the task better to figure out if I have multiple workflows, which workflow do I select, if I within a workflow, which job do I post, when do I know that my work has been done at a high quality. If I have a worker who is good but has some hole in their understanding, when do I teach them, when do I test their quality, and so on and so forth. So, we have done a huge, a reasonably large body of work in this space, and let me just give you a couple of quick examples of the things. So, for example, everybody starts out with these simple yes no questions. Is this bird an indigo bunting? Now, I can ask several of you, and some of you will say yes, some of you will say no, and hopefully people who know this thing will give us answers, but they may make mistakes. So, can we do some kind of consensus on top of them? But not just consensus, when do we know that we have a good quality answer, and when do we know that we need to ask more people? That becomes a decision theory question. And so, when using POMDPs in a cost control setting, if we did dynamic optimization, dynamic sequential optimization, we got much higher accuracy than the static controller for the same cost. So, this got us interested, but then we went to more complex tasks. Suppose this is your doctor. He wrote this nice thing for you. Now, how do you know what is going on? So, you can give it to a crowd worker, and in 27 cents, in this particular case, they were able to get the full transcription using a very interesting workflow, but they didn't know how to optimize this workflow. We did. So, when we optimized this, we found that we were able to use the same amount of money, but get much higher quality of image transcription and so on. We have done taxonomization of all the items, and again, one of the graduate students who was an HCI graduate student came up with a very creative workflow to do this taxonomization, but she was not a optimization person. And so, when you model this for optimization, you find that for 13% of work, you can get the same quality if you use optimization carefully. We have many examples of this. Like if you have lots of workers with varying ability and you have lots of questions with varying difficulty, we know which particular worker to give each question to, and again, red is our thing and higher is better. We have thought about when to test a worker and when not to test a worker, and again, higher is better than we are the red one. We have thought about when to train a worker and what to train a worker on, and again, green is what we could eventually achieve, but we were able to achieve red in our experiments. And in the latest work, we have done not just quality cost optimization, but we have also done quality cost completion time optimization. If I start paying each worker more, then more workers will take my job, my time will reduce, but my budget will exhaust quickly, so I will not be able to solve the whole task, so my quality will go down. There is a very interesting interplay that happens when I start doing this three-way optimization, how to manage the whole optimization. So, I am able to use my budget the best, including with the parameters that I have in my task. We have a latest paper coming out. So, at a high level, we have looked at intelligent control and optimization in the context of smart crowdsourcing. Crowdsourcing has a lot of advantages, but there are some challenges to be resolved. For example, we can figure out what to ask, how many times to ask, who to ask, when to teach, when to test, when to stop. All these actions can be taken by our AI agent using POMDPs as its base. And we can do it for data quality. In other work, we have also done it for classifier quality. If I am in an active learning setting, then I can use workers very effectively. And from our point of view, from an AI minded person's point of view, it's a small step towards the vision of human intelligence and machine intelligence coming together to achieve something bigger. In our more recent work, we are now not only thinking about democratization of workers, but also thinking about democratization of requesters. Suppose you as an individual want to give out a crowdsourcing task. Can I make it easy for you to crowdsource? There are a lot of good practices, but it's not very streamlined still. You don't know how to make the right task. You may be confused about your own task. You may not know what the workers are getting confused about. How do you improve the task design? So, we have done an HCI interface where we will give you the interface that will allow you to learn your task better using interactions with workers. So, this is the work that we have done in the context of crowdsourcing. I also wanted to add that in my other lives, I do research in natural language processing, and recently we have started two very interesting projects. One is on analyzing legal data sets. So, lots of court data in Indian judicial system has been languishing, and we have started analysis to understand which courts are outperforming other courts, which districts are doing well, which districts are not doing well, where are the cases getting stuck, so that we can inform the legal department someday. And in second project, we have started a healthcare initiative where we are trying to read MRI images and CAT scans automatically to see if we can help the radiologists do their job more effectively. And since we are talking about social good for young people, I have also advised a dating company to help you find your right partner. So, so there is a lot of very interesting stuff that we can do as an AI person in the mix. But I always feel that until we get the right partner to partner with, who is a domain expert, it's a non-starter for us. So, in the remaining time as we are doing these discussions, I would love to hear more about interesting problems from domain experts where AI people can actually help contribute. So, I will stop here.